Fantastic. Thanks, Louise. And yeah, thanks very much for inviting me. Great to meet you all. Thanks for joining. I hope you find the talk interesting, and I'll look forward to taking your questions at the end. So as Louise mentioned, so my name's David Hardcastle. Excuse me, I had a little bit of a cold over the weekend, which I know nowadays is not always the best thing to say, but I hope that'll pass quickly. I'm the site leader for Amazon Cambridge, and I'm also, my day job, as it were, is a tech director within Amazon, so leading software teams, building software for our customers. So yeah, thanks again, Louise and Cambridge Network, for inviting me. I'm sorry we can't have you round to the building in Station Road and ply you with brownies and coffee and things, but hopefully we'll be allowed to do that someday in the future. In the meantime, great to get to meet you and talk to you today on Zoom. So thanks for setting that up. As Louise mentioned, I cover a couple of different things today. So I'll talk a little bit very briefly about sort of our growth in Cambridge and how we've got up and running, where we started from. I'll tell you a bit about what we're doing. There are so many different teams in Amazon Cambridge. I can't cover all of them, but I've picked a few out to give you a bit of a sense of the variety of different work that we're doing in Station Road, or currently from our various living rooms with the hub in Station Road. I was going to share some tips. I've been a tech leader at Amazon for quite a few years, so I've got 2 or 3 tips to share with some of you if you work in the tech sector, some ideas about how to lead teams that work in high growth or high innovation areas, what we do at Amazon, some of the things we do to help us with that. And then I want to talk a little bit about some of the partnerships that we have with organizations around Cambridge, and also our Amazon Future Engineer program that we've been working on across the UK. So that's what I'm going to cover. I hope you find it interesting. Start a little bit with our journey in Cambridge. So I joined in 2014, a little bit after the acquisition of EV. EV is an AI startup that spun out of the university here in Cambridge and built a question answering app that was acquired by Amazon as part of the lead into the launch of Alexa in 2014. So when I joined back in 2014, there were about 30 of us in Cambridge, really just the EV team. Over time, Amazon Cambridge has grown, as you can see on the screen there. We still have, excuse me, we still have an office in Castle Park. We also have the one in Station Road. In fact, we're now in 2 different buildings, or we'd like to be back in 2 different buildings in Station Road, as we've grown from about 30 in 2012 through to around 1,000 9 years later. So the main takeaway there is just we love being in Cambridge. It's a great place for Amazon companies to come. You can see lots of different parts of the business have come to Cambridge because there's such a diverse tech sector here. There are people with a great specialism and skill sets and experience in lots of different areas. There are autonomous vehicles, in AI, in building software infrastructure, all sorts of different things that Cambridge companies specialize in. And so we love to be here, and we've created hundreds of tech jobs in Cambridge over the last few years. And obviously we're here to stay. We've made a big investment in the centre of Cambridge, working with lots of people locally around Cambridge as well, and we'll continue to create more and more tech jobs. And I'll tell you about some of the companies or some of the teams within Amazon that are here in Cambridge that are continuing to grow over the next few years. In a nutshell, some different areas that, as I mentioned, the sort of diversity of what we're working on. There's people working on AI and machine learning, computer vision, autonomous delivery, internet scale infrastructure. There's some really very different challenges there, and some different types of software and different types of role that fit those together. I think where the sort of some of the common fabric, if you like, the common DNA of what we're doing in Amazon Cambridge is, firstly, all of the teams in the Cambridge office are building real products for real people. We're building real products. We have global customers, so they tend to be at quite big scale, but there's none of what we're doing is kind of, we don't have a concept in Amazon of like an R&D center where we're doing something that's purposefully offline. Everything we do, we're wanting to bring it to customers as much as possible. We're always setting out, when we innovate, to solve problems that customers have or find ways to delight our customers. That's where we always start from. To do that, we need to tackle state-of-the-art applied science or engineering challenges. So we're working in these areas and some others as well in Amazon Cambridge. We're working on some really state-of-the-art problems. And of course, as I mentioned, that brings us into a whole bunch of very, very varied technologies, different product spaces. We tend to have highly cross-functional teams with lots of different people with very different backgrounds and very different roles and job titles working together. I think that's very much what sort of present technology looks like versus maybe 20, 30 years ago, where it was a little less diverse in terms of the skill set and in terms of the sort of whole software process was a bit less cross-functional than it is today. So I'll tell you a little bit about Alexa AI, start there with what some of the teams in Cambridge have been working on. Excuse me, and perhaps first to give you a little update on where we are in our journey with Alexa. So I've got these sort of 5 areas. So we've made great strides with Alexa since we launched in 2014. The business has expanded. We have a global customer base, and we've launched a huge number of features for Alexa. So what are we working on at the moment? I think where we see the way forward with Alexa, and so these are some of the sort of categories, if you like, the key areas of where our scientists and engineers are focusing on in order to live up to the customer promise that we've built up with Alexa. Self-learning, super interesting for us. We want Alexa to continue to be more and more knowledgeable, to be smarter and smarter. And so we're really investing in a whole bunch of different applied science techniques that drive self-learning and allow Alexa to scale to every customer. We want Alexa to be more and more natural over time with some work that we're doing in Cambridge, which I'll tell you about, that fits into that. That can be Alexa's voice. It can be the vocabulary that she uses, her ability to adapt to different situations. Of course, we want Alexa to be more knowledgeable. That's something that Evie, the startup that we bought back in 2012, has always been at the forefront of making Alexa more knowledgeable. We also want Alexa to be more context aware and more conversational. As human beings, we make great use of context to deal with concise communication, to deal with to show common sense, to come up with the right answer to the question, because I know about you, the person who's asked it, or I can imagine what you're really trying to get done when you start a task or you're searching for something, you're finding out about something. So how does Alexa become appropriately context aware so that she can be as smart and as helpful as possible for customers? And of course, can we make Alexa more and more conversational? We've launched recently things like Alexa Conversations for skill developers to help our skill developers and our teams within Amazon as well build more robust, more resilient interactions. So I can really have a conversation with Alexa and take that to the next level. So in Cambridge, a couple of things that we're working on. As I mentioned, Evie has been working since acquisition on making Alexa more knowledgeable, in particular building up Alexa's knowledge graph. So by a knowledge graph, I mean a digital representation of the world. And it's a really interesting place to work. The knowledge graph, we want it to be a high fidelity representation, or as high fidelity as we can make it, of how things really are in the real world, what things there are that customers are interested in and how they relate to each other. But it also needs to be tractable. We need to be able to build software that we can test that works on it deterministically. We need to be able to fill the knowledge graph with data that obviously comes in various different representation and has different formats. So there are lots of interesting challenges building and maintaining a high scale knowledge graph, trying to make sure that Alexa knows all the things she needs to delight customers, whilst also being able to make that work in a deterministic way and make it work with the various different ways of representing information that Alexa encounters when acquiring it from either within or without Amazon. So you can think of a knowledge graph. I think a couple of key things to take away. Some of you may be already expert on knowledge graphs and knowledge representation. So entities are core to most knowledge graphs. So each of the things in the knowledge graph, like say Rosalind Franklin would be an entity, Cambridge would be an entity, the United Kingdom is another entity. All of the different people, places, events, the things in the world, each of them is an entity in the graph. And entities are connected either to each other by relationships. So a city like Cambridge contains various different electoral wards, like Cherry Hinton, for example. So there's a relationship between Cambridge and Cherry Hinton. Cambridge also has properties, like it has a population, for example, or a latitude and a longitude and so on. So we can define in the graph these different types of things. We define them as classes in our ontology, our type system. And the ontology is really useful in the knowledge graph because it means that we can build reasoning systems that can reason about the types of things that a city, for example, the ontology tells the system what types of property, what types of relationship something like Cambridge can have, and that allows us to build common sense rules so that we can make sense of the questions that we get from customers and tie the thing that you say to Alexa back to the facts that we have in the graph. So put that into action, the knowledge graph at work. What about if I ask, is the gherkin taller than the shard? That's surprisingly tough. It might seem fairly obvious to us. We know the gherkin is that stripy oval object on the left, that building. The shard is the famous big tall building on the right. There's actually quite a lot to do for a computer system there. A gherkin could be a pickle. It has a height, I guess. It's probably about 0.5 centimeter. That's a lot less than the shard, but that's not very helpful for a customer. So we've got to understand the vocabulary. We've got to, for each word that we say in English, there are lots of things it could refer to. So those classes that I mentioned are useful in having Alexa figure out a sensible interpretation of what I said from the many, many different things that I might have meant. Then she's got to go and find the relevant facts in the graph. Hopefully we know about those buildings, we know about their heights. We understand what taller means, that we've got to go and find the heights of different things and make a comparison and figure out which is the larger number, make sure that they're in the same units and so on. Then we've got to generate some text and then speak it back to the customer. So that whole process of understanding a question, reasoning about it, finding the facts, generating the answer, that's a key part of what the Alexa AI team do in Cambridge, and that's something we've been doing since we acquired Evie back in 2012. One of the other Alexa AI teams that we've got is the text-to-speech team. They do speech synthesis, and so one of the things they've been working on in the last couple of years, we talked a bit about Alexa being more knowledgeable with the graph. Well, here with the voice, really talking about Alexa being more natural. So it's very hard to synthesize speech in a way that is natural and sounds human-like. And that's what this team have been working on. Over the last couple of years, they've introduced neural text-to-speech models that allows Alexa's speech to seem much more human-like, both because we can have different styles of speaking for example, discourse or long text versus short answers. We can also introduce different emotions. So Alexa could be disappointed or excited about something that she's telling you. And also it allows us to deal with the challenge of what we call out of vocabulary words. So the number of things that Alexa knows about, she's constantly acquiring new labels like the gherkin and the shard and various other things in the world that she needs to be able to talk about. And she wants to talk about those in the most natural vocabulary that our customers use as well. That's an endless challenge for teams like the text-to-speech team to keep up with. So that's another area where building these kind of smart or intelligent systems, building using things like neural nets in order to solve that, allows us to cope with unseen cases, which is a really interesting challenge for us in text-to-speech. So there's a couple of the AI teams that are working in Cambridge and some of the things that they've been doing. Lab 126 is an inventive research and development company. They have a team around the world, including teams in Cambridge. They're the team that developed the Kindle a while ago and have developed some other devices over the years. One of the recent things that the team have been working on is the Echo Show 10 that you can see here. Echo Show 10 is really interesting from the perspective of a customer. In my case, for example, my mum likes to call me on a Sunday evening on my Echo Show. I don't have an Echo Show 10 yet, so I'm generally cooking on a Sunday evening, and I have to keep walking over and I talk to my mum a bit, and then I go and do something in the background, and then I come back. If I had an Echo Show 10, it would pan round automatically, keep me in view. I could be mobile while having a video call, but I'm always on the screen with my mum, so we're having a great conversation. So there are various other use cases to the Echo Show 10, but that's one of the key ones, is being able to have that adaptive video conference experience. And the computer vision tracking, and the integration between the motorized design that we have here and the computer vision aspects of it, that presented some really interesting engineering challenges, and the team in Cambridge have been part of the work to get that working and allow this flagship launch that we had just recently. Here's some of the other devices that they've worked on. As I mentioned, Kindle is really where Lab 126 started, but also we have Alexa-enabled earplugs, Alexa-enabled rings, various different screened devices, Ring, of course, with the smart doorbells and various other things as well. So Lab 126, really interesting team in Cambridge, very, very different from what we're doing in the Alexa AI team, but often coming together to build things for customers. We've also got some AWS teams in Cambridge, and one of those is the Simple Storage Service, or S3, since there are 3 S's there in the title. So S3, really interesting part of AWS. There's a huge amount of data. There are literally millions of applications that rely on S3 from companies all around the world. And S3 is designed for really industry-leading availability, security, and performance. So that the team aim at 11 nines of durability. So 99 point, and then 9 nines, and then a percent. That is the that's the level of resilience that the S3 team set out to achieve with a very, very large amount of simple storage around the world, supporting lots of very, very different applications. So one recent feature that the S3 team have launched is called S3 Object Lambda. The problem they're trying to solve here is that if, as an application owner, I have multiple different applications that access the data in my S3 bucket, but I want to give like a different filtered view or an augmented view of that data, then I can either make multiple redundant copies of that data with perhaps a different set of fields included or not included. Like maybe I want to have a copy of my customer data with all the personally identifying information, all the PII stripped out, and then I've got to figure out which S3 bucket, which application gets access to, so that I can keep control of the data. Alternatively, I could build and manage a whole proxy fleet, a proxy service in front of that to do that kind of filtering. So S3 Object Lambda gives me a way of managing that without having to build a proxy fleet, manage any servers. I can do that through AWS Lambda, which is a serverless compute. So I can just define the functions that either add or remove, or in other ways change the data from the S3 bucket, and then I can build that into the GET request that the application. So from the application developer's perspective, I just get data from the bucket, but the people who are the team that's responsible for managing that S3 data store, they've now introduced some rules that give me some sort of filter or some sort of augmentation to the data. So it's a very powerful way of bringing 3 things together: a managed service where Amazon takes away some of the complexity for me as a developer. It simplifies for the team who own the data, because it's much easier for me to run the data store, but it also simplifies for me as the application developer, excuse me, because I don't need to worry about putting this extra logic in the application layer. Lots of great examples of use cases that drive this innovation in the S3 team. Image reformatting, for example, is one that it speaks to me. I've got a team responsible for a similar kind of, as part of Alexa, I have a team that is responsible for managing images and serving up those images. So the ability to hold all your images in an S3 bucket and then build logic in that's perhaps different for different applications, like watermarking, for example, or rescaling, this kind of thing, then that's super helpful to be able to do that and separate encapsulate the storage from those extra retrieval functions from the developer. So that's S3, team in Cambridge, S3 Object Lambda, something they've been working on. A couple more things to share. Managed streaming for Apache Kafka. Similar kind of thinking in some ways to what we've done with S3 Object Lambda. So this is a fully managed service that makes it easy for you to build and run applications that use Apache Kafka to process streaming data. So there are lots of use cases for Apache Kafka. If you work with streaming data, you're probably pretty familiar with logging, control metrics, lots of people around Cambridge doing things like energy monitoring, IoT, home automation or enterprise automation and so on. So you're probably used to working with streams or doing analytics on data. And Apache Kafka is a great open source platform for building real-time streaming data pipelines and applications. However, again, as a developer, there's a difference between sort of taking those streams and building my first few sort of happy path cases, if you like, just getting something working. How do I get it to high availability? How do I add in all of the complexities around my own logging, audit capability, security, perhaps different auth and auth roles for different third-party integrators or different parts of my own enterprise application space. So that's where the managed streaming for Apache Kafka, MSK, really comes in, because it integrates for you a whole bunch of different AWS services that do things like authentication, that do deployment, that do give you help with testing, logging, instrumentation, and so on. And certainly, as a user of AWS services myself, of course, this is some of the areas where I think in cloud computing, it starts to really add up to a great value proposition, where I can focus on building the application, and all of those extra sort of horizontal concerns around scaling, security, deployment, testing, instrumentation, and so on, they're all managed in some serverless way, and I don't have to worry about a whole bunch of servers, and I don't have to worry about a whole bunch of sysops that I don't really want to pay attention to, because the application is the bit that's core to the business that I'm running. And so that's where I want to put all of my energy and all my thoughts. So there's a MSK and S3 Object Lambda, both examples in Cambridge in the AWS teams of helping their customers, their developers, to simplify and focus on the application space that they want to. One last quick update is about Amazon Scout that you may have come across. So Scout's Amazon's fully electric autonomous delivery service. Each of these devices is about the size of a small fridge. They roll along the pavement at a walking pace. Currently, Scout is in field test in the US in 4 different states. We're looking to expand over time. I'm afraid I can't share any more details about the specifics of that, other than to say that we do have a team in Cambridge, which is fairly recent, that we've got stood up. We're still hiring there. We're looking to put dozens of engineers in Cambridge and have the Cambridge team work in partnership with our Seattle engineering team. We'll be working pretty closely with the research lab for Amazon Scout, and we'll be particularly interested in working on how these Scout devices are going to safely and autonomously navigate pedestrians, pets, recycling bins, whatever it is that they're going to encounter as they roll slowly along the pavement with your Amazon delivery in. So that's Amazon Scout. And now I'm going to sort of just actually before I go to the next section. So there's some of what we're doing in Amazon Cambridge. We're building things like Scout. We're building infrastructure like S3 and Kinesis and MSK. We are building Alexa AI. We're building pretty cutting edge technology around voice, around speech, around AI and reasoning. As I mentioned on that first slide, actually a bunch of other teams in Amazon Cambridge as well. So we've got this very diverse set of teams there and very diverse set of roles, as I mentioned, very cross-functional teams working in these often very new areas. But always, as I mentioned, there's always a thread there about customers. There's no abstract R&D where we're just off in the background doing something that may be useful someday. We always start from the customer at Amazon, and that means we're always close to launching something because that's why we're innovating. So how do we innovate at Amazon? As I mentioned at the start, here are a couple of tips. There's tons of different things that we do. Of course, across Amazon, we've got lots of different working practices to help us grow and to help us innovate, to help us manage at scale. So I've just picked 3 for today in the interest of time, 3 things that I think sort of fit together and for me are sort of working practices from Amazon that I find particularly helpful in leading teams that are innovating. So the first of those is, as I just mentioned, working backwards from the customer. I think it's a really important part of how we do research at Amazon, and we write what we call working backwards documents, or sometimes you may have seen on the internet or you may have heard about PR FAQs, where we write literally we write a press release where we talk about how impactful this thing that we want to build is for our customers. And then we have a series of FAQs where we answer some of the technical and research and business risk questions that go behind that. So we always want to start with this notion that we can write down what it is that would make this piece of research or piece of engineering that we're about to embark on, what would make it count? Is it going to revolutionize something that our customers do, that we're going to remove friction, it's going to make something easier? Is it going to delight our customers by allowing them to do something in some different way? What does it unlock, and why would customers care about it? And we always make sure we start from there. I think it helps us make good decisions, helps us be intentful and deliberate about where we're investing our research. Of course, we then also need to tie our research back to our own broader research agenda and think about where that fits in terms of the state of the art. But we always start from the customer. And I think also as an engineering leader and a people manager, I think it's great to have these working backwards documents so that everybody who's on the team ultimately has a kind of unity of purpose in knowing what we're trying to do in the real world for real people, whilst we're taking on some really difficult engineering and research challenges, some of which may not work out. We may have to rethink and start over and try some different tack. The fact that we've got this North Star aim of where we're trying to get to is really helpful to motivate us to take on such high risk work. So that's the sort of first tip, is always work back from some really convincing use cases for the customer. If you don't have those, perhaps you're not ready to start yet on a research or engineering agenda. Second is the importance of writing. I think if I think of all the things I've learned at Amazon, I think it's probably one of the most important. Is I've learned to be better at writing, but I've also learned about the importance of building written mechanisms into how I run the organizations that I lead. I think there's a number of different aspects to it. I think writing is very inclusive. I think if you work in an environment that has a very presentation based or get around the table and talk it out based culture, then it can be hard for everybody to fit into that. Some people prefer to take time to digest information, and some people prefer to take time to reach a decision. So that the Amazon practice of actually sitting in a room and reading in silence the whole of a document before we have a discussion is actually very inclusive one, I think, and it's very empowering for the doc author. So a couple of things I take away writing, and these tips are on the Fact of the Day blog, which you can find on the internet or on LinkedIn. It's got some great insights, not always drawn from Amazon, from lots of different areas of the tech sector. Have a think about the second one in particular is really interesting. We made the on-time delivery rate much higher, which is very easy to write. I could write that sentence with very little knowledge of what I'm talking about. What about we increased the on-time delivery rate by 15 basis points from 97.1% to 97.25%? There's a writing forcing function for making sure that whoever's writing this doc really knows the bit of the business that they're in, and they know how the technology that they're responsible for connects to business outcomes, and they can articulate it. They can talk about that relationship because they know their numbers, which is a bit of an Amazon mantra. Do you know your numbers? Do you understand the relationship between the data and the instrumentation on the technology and the dynamics in the business and ultimately the customer? So various tips that we have here, and just thinking about having a really strong writing culture is a great way of having a thoughtful culture where you actually you make decisions based on a deep understanding. Doesn't stop you moving quickly, just means you set yourself up for success by making sure you understand the relationships and dynamics within the space that you own. And the other, as a leader, I think it's very empowering to be a good writer. If you can write concisely and you can communicate concisely, then you get to choose what you're going to say to the people who read your emails or your reports or whatever your written artifacts are. And that is such an empowering thing as a leader. I think when I joined Amazon, I was very much I will tell you everything I know about this subject writer. And of course, that just means that I'm creating work for the reader, of course, but I'm also leaving the reader to decide which of the things that I know they want to talk about. how about I make that decision? That's a much more empowering place for me to be. And then the third thing is, once we've done that working backwards process, and we've written some great artifacts, and we've decided on a new idea and we're going to commit to it, fast experimentation is essential. And the reason for that is because in many of these areas, there's still a lot of ambiguity, even after that working backwards process, even after those great documents. You don't want to stay in ideation mode until you've nailed down every single piece of the puzzle. You want to get moving, and so you need an experimentation loop to do that. You want to maintain an appropriate bar. You shouldn't put stuff in front of customers that you're not proud of. You should always be proud of every release that you make. But there's always an opportunity to learn. And if you've built the right loops, if you've built the right feedback mechanisms, you can keep learning from a production environment. You can learn from your customers. And we're finding that some of the serverless components that are available nowadays, of course, we're using the AWS ones, but things like Fargate, Lambda, S3, Kinesis, they make it really easy for us to build these fast experimentation cycles. So that's really helping us. So there's 3 tips for you to think about. So working backwards process, concise and crisp, data-heavy writing culture, and then a fast experimentation loop once you get into production. For me, those are 3 critical ingredients that connect together in the recipe of leading a team and is able to innovate in production. And then I wanted to share, lastly, a couple of just some of the things that we're working on in the wider community. So we've got a number of local partners that we work with around Cambridge. Excuse me, in particular, Form the Future, Career Ready, Makespace, among others that we work with or support in various different ways. What I actually wanted to tell you a bit about today is this slightly sort of broader program, a UK-based program called Future Engineer, and I put a link to the Amazon Future Engineer co-UK website there if you want to click into that and have a bit of another look at it in more detail. So we've got a bunch of different streams of work going on in Amazon Future Engineer. What we're wanting to do is to build a comprehensive program where we can enable young people and adults to find their way into computer science, or potentially also into the tech sector. All of us, I think, working in the tech sector are aware of the fact that we're making progress, I think, as a sector, steadily in the sector becoming more diverse and more inclusive, more representative of our whole society over time. But most of us, I'm sure, and myself certainly, would like us to make faster progress. And so that means we've actually got to do things differently. We've got to invest in programs like Future Engineer, as well as the things that we're doing within our own office environment or within our own staff in order to promote diversity, equity, and inclusion in the tech sector. And so Future Engineer is an important part of what we're doing in the UK to help that. And I'll talk to you briefly about 3 different pieces of it for 3 different age groups. And that's not the totality of Future Engineer, but hopefully give you a bit of a taste of some of the things that we're up to. So firstly, a couple of the things we've been doing for 5 to 11-year-olds for primary school age children. So we've been doing robotics workshops in some of our fulfillment centers, excuse me, around the country. I'm just going to stop for a very brief water break, apologies. So we've had 3,200 students participate in those. Unfortunately, lockdowns made it a bit difficult last year for us to continue with that. We're actually working on a version of those robotics workshops that we can do in a different way so that we're not curtailed by lockdown. But in the meantime, we've also been working with the code.org organization on Hour of Code Dance Party, which is a collaboration between Amazon and code.org to create an interactive dance-themed online coding tutorial. So as a workaround during lockdown to these robotics workshops that we've been doing. So there's that and other things that we've been doing with 5 to 11-year-olds, supporting primary school children, getting an interest in computer science and learning a bit about what's involved, also starting to build their enthusiasm as well as some of their skills and their confidence. I think some of the young people that we've spoken to over the years, they do feel dissuaded from a career in computer science. In particular, I think underrepresented minorities and young women seem to be dissuaded from technical careers, often by well-meaning teachers or others in their lives. And I think there's an opportunity for a program like Amazon Future Engineer to change that. Secondary school, so 11 to 16-year-old. One of the things we're doing is working with the charity Teach First to support the recruitment and training of computer science teachers and the development of careers leaders. So that's teachers who've got an extra responsibility in their school as a career leader to develop career programs. So we've done a lot of work with Teach First. We have supported the recruitment and training of over 50 secondary school teachers and 200 career leaders across the UK, and that's an engagement that we're still moving ahead with. Teach First. We'll see more coming along that way, but we think we'll help 50,000 students. I can't remember the exact timetable for that. Apologies for that. But in the future, we will help over 50,000 students through this program working with Teach First. I think it's really important to give more secondary school students, especially targeting schools where computer science hasn't been an option. And you can see some of the statistics from the Royal Society and the Department of Education there, giving everybody the opportunity, if they're interested, if they have the affinity and the enthusiasm, to find their way into a tech career if that's an opportunity that they want to take on. And then the last one, which is something that's close to my heart, this is a project that I've been particularly closely involved in, is the apprenticeship program. You may think of apprentices as being particularly around like physical work or physical machinery and so on, but actually we also have software engineer and data specialist and solution architect and so on. We've got apprentice roles where we now have apprentices in Amazon in the UK who are earning as they learn. They're working for Amazon, they're part of an Amazon team. They're not just doing the photocopying or something, they're properly part of a Scrum team working on doing software engineering, building software in production for real customers on our real products, along with the rest of the team. And we get our apprentice software engineers into that production environment with the team as quickly as possible, because we want to make it the most fulfilling environment for them as possible and create the environment where they can learn. So to make that successful, we need to train and support the software managers and other software leaders that those apprentices are going to be working with, so that we can make sure that the program is successful. And then, of course, we also work with degree awarding partners so that our software engineer apprentices are working in Amazon some of the time as part of the team building software. And then they're also studying some of the time. And that's not studying in the evenings and at the weekends. That's they have time set aside where their day job is to do their studies or take their exams and progress through their computer science degree. And then there are other times where their day job is to be part of the Scrum team, building software and building in some of the organizations that I just told you about, like Alexa AI and S3 and so on. So software engineers, data specialists, solution architects, we've got these really interesting tech roles where we've been able to craft an apprenticeship for young people. We have about 100 apprentices across the UK in these tech roles at the moment, 20 of them in Cambridge. And that's something that I hope will continue to develop and grow that over time, and we'll get more and more apprentices coming through. And one of the things that's, I think, really going to help us with is it'll help us help some of these young people avoid some of these filters that currently filter out talented young people who could very easily come and work in any of the tech companies around Cambridge if we can just give them the opportunity to come and show us what they're capable of. So that's the apprenticeship program. And again, there's a URL there if you're interested in finding out more about Amazon Apprenticeships. So apologies for the water breaks along the way. Hopefully my voice will hold out to the top of the hour, but I hope you found that interesting. And